Welcome to our fourth video installment in our Design a Ride series here at Magictecture, where we're working on designing our next backyard roller coaster. This episode is titled The Coaster. As always, I really encourage you to like this video and subscribe to our channel if you haven't already done so. Additionally, we just launched a Patreon account to help support our endeavors. If you're not familiar with Patreon, it's a great tool that allows our fans to contribute in an impactful way. It's really only through your generous support that we're able to continue to bring this type of content to you, so thank you in advance for everything you're doing to help us out. Alright, so first, I'd be remiss if I did not recognize the backyard roller coaster greats that we've been inspired by. We're really standing on the shoulders of several backyard roller coaster pioneers, and there's no way we would have even attempted our first ride without their efforts and willingness to share their experiences with the community. Two individuals that I'd like to give a special shout out to are Will Pimble and Paul Gregg. I believe Will Pimble is pushing the boundaries of backyard roller coasters in a way that no one else really is. His commitment to the art and enthusiasm are contagious and something that we really are striving for with our channel. Paul Gregg is one of the kindest and most generous individuals that I've had the chance to interact with. He's truly an expert in his field, and I recommend his book on backyard roller coasters if this is something that you're really considering doing. There's nothing else out there that's nearly as detailed and informative as his work, and you'd be remiss to begin building a backyard roller coaster without looking at it. If you haven't seen their work, check them out. I've put links to both of their channels in the description box for your convenience. Okay, so getting to our coaster and how we approach designing the track. If you recall from the past two videos, I have the beginnings of a story, the landscape, and the setting. With this knowledge, I began drawing out our track in plan view, where I draw a continuous line which passes through the various sections of the storyline we're trying to convey. During this step, I'll block out the sections of the ride which pertain to the action that I'm trying to have occur during the specific portions of the ride. For example, the lift hill, drops, turns, launch, etc. Now for those unfamiliar with construction documentation, plan view is just looking from a bird's eye view, from the top. Once I have this continuous line, I switch my view from plan to section. Section view is from one of the four sides. Now as I go along the line path I've created, I change the elevation up or down to ensure that I have the proper clearances throughout the entire ride. Now the track for the Alpine Escape ride had a width of 24 inches, but we wanted to give ourselves more stability on the ride, so we've increased our track width to 30 inches. In Rhino, I offset this continuous line 15 inches in each direction to give my left and right track. I then use the pipe command in Rhino to generate the round tubes for each track. This gives me a pretty accurate vision for the ride, and I'm really able to see the track, which I just get really excited about. Now, when approaching the track design, I have three factors in mind: thrill, physics, budget. Obviously, I want to get the biggest bang for my buck, and so I'm trying to make a thrilling ride out of a relatively small backyard roller coaster. For this reason, I've designed an accelerated launch at the very beginning with a lot of sharp turns and a few drops. As this is a backyard roller coaster, I have to act within a reasonable budget, which really limits the scope. So for instance, the height and the length of the coaster. However, with some clever design, we're able to capitalize on our ride experience, incorporating some thrilling sections throughout the ride. For instance, I've placed an accelerated launch early on the ride, setting the tone for the experience. We're doing this by using a compressed air system, similar to Will from London. I've included a link to his video below. Now we're able to ensure that the riders have a huge adrenaline rush at the beginning of the ride by doing an accelerated launch. And in a future video, we're going to show you how we came up with our calculations, the materials, and the assembly. The greatest thing about this system is that you're able to create a really thrilling ride experience with a minimal amount of track. The second and more complex part of the ride design is designing what to do with the potential energy that you've created with your lift hill. We're able to calculate the potential energy of our coaster at the top of the lift hill because we know how high the ride is and we know the approximate weight of our cart. We need to conserve as much energy as possible with the design of our ride so that the cart doesn't lose so much energy as it's going through it. This is done by calculating the height and length of the dips and then determining the banking that's optimal for the ride as it goes along. Now you can analyze these factors by calculating the initial potential energy to determine the velocity at key moments on the ride. I learned a ton about this from Paul Gregg's book on backyard roller coasters, which is titled Backyard Roller Coaster Research. I've put a link into the description box below where you can purchase his book, and I highly recommend reading this. It's really been invaluable to me. For a great synopsis of the physics of a roller coaster, I recommend watching Roller Coaster Forces Explained by CoasterBot. And if you're a glutton for punishment and want to see someone go through all of these equations, I found a great video from the organic chemistry tutor where he walks you through some of the different steps. As you can clearly see from all of those videos, designing the physics of a roller coaster is quite complex. Exercise caution when approaching this step and consult with experts who have knowledge, time, and experience in this field to run all of your calculations. Failure to follow these steps could result in serious damage or injury. That said, science is amazing, and the limits of what we're able to do with science are constantly being pushed. I encourage you to push the limits of your coaster and see how you might be able to overcome some challenges. And as always, have fun. This concludes part 4 of our design ride series. In the next video, I'm going to be walking you through our cart design and how we're approaching that. Look forward to seeing you there, and until then, take care.